So we have some description about this. So the execution sequence that we have described are called as schedules, right? So you have a schedule where it's a serial schedule T1 followed by T2, and the next schedule was a serial schedule T2 followed by T1. Right? So they represent a chronological order in which the instructions are executed in the system. Right? So a schedule for a set of transactions must contain all the instructions of the transaction, and it must also preserve the order in which the instructions appear in the individual transactions. Right? So whenever you create a schedule, it should preserve all the instructions in the transaction, and again the relative ordering of the transaction should be preserved. Right? So each serial schedule consists of sequence of instructions from various transactions, where the instructions belonging to one single transaction appears together in that schedule. Right. So however, when the database system executes several transactions concurrently, the corresponding schedule no longer needs to be serial. So if two transactions are running concurrently, the operating system may execute one transaction for a little while, then perform a context switch, execute the second transaction for some time, and switch back to the first transaction for some time, and so on. Right. So in real time, we don't have serial schedules. We also have concurrent execution of these transactions. Right. So what happens in a concurrent execution of a transaction is that the operating system will be allotting the CPU time between the different transactions. Right. So the operating system may be executing the first transaction for a short time, then it performs a context switch, executes the second transaction for some time, right, and then switch back to first transaction, and so on. Right. So let us see what happens if the transaction is executed concurrently. Right. So both the transactions are going to be executed concurrently. Right. So we are going to start with the transaction T1. It is executed for a few seconds, right, by the processor. Then the operating system performs a context switch of the processor to the second transaction. So again, second transaction is executed for a short time. Then it moves on to transaction T1 followed by T2. Right. So now again we need to check whether the consistency is preserved in the database system while you are going to execute the transactions parallelly or concurrently. Right. So let me get some. Right. So someone can solve this problem, right? So who is interested?
Yes, sir.
Yes, sir. It's the same as the first case which we saw.
Subramanian,
It will
right?
be. Sorry, sir.
So what's your name?
Subramanian.
Subramanian, right? Subramanian, can you get me the intermediate steps? So
sure, sir. So first we'll be subtracting 50 from A, which is like from 1000 we'll get 950, and then again, since we are doing since we are doing it again for like A, we'll like get 10% of the value that's currently present at A. 50 we like subtract 95 and then have it in the variable temp, and the final value of A would be 855, and then we move to B and then we add 50, which gives 2050, and then the value at temp, which is 95, would be added, which will give 2145. So if we add both, we'll get 3000. So the whole transaction is consistent.
Right, Subramanian, correct. So the thing is that here you are going to execute concurrently two transactions, T1 and T2. Right, Subramaniam said that initially A value is 1000. So once you run the transaction T1, A value will be 950. Then you execute the transaction T2, temp value will be 95, and the final value of A will be 855. Similarly, that you perform a context switch. Transaction T1 is executed, B will be 2050. Again, you execute transaction T2, B value will be 2145. Right, so the output will be 2145 plus 855. It's going to be 3000. So we say that even the transaction is executed concurrently, it is consistent. Right, so one possible schedule, right? So this is one possible concurrent schedule where after the execution takes place, we arrive at the same state as the one in which the transactions are executed serially in the order T1 followed by T2. So here the thing is that consistency properties preserved. It looks like for this concurrent schedule, the the consistency properties are preserved even you have the concurrent execution of this transaction, right? So now let us look into this schedule. So there was a context switch at different points. Here we are going to have context switch at different points. So what happens here? You can use a piece of paper, work out. So what's the initial value of A?
1000.
Right.
And then A will be A minus 50, which will be 950. Then temp value will be A into 0.1, which is 95. And we'll subtract temp from A,
So that's
which will be.
So that's it. Sorry, you made a mistake here. The thing is that A is going to be 1000. 1000 minus 50. Are you writing the value of A? You are not writing the value of A, right?
Yes, this will be
You are
1000.
performing a context switch and you are going to compute 10% of A. So again, you are going to compute 10% of A, which is going to be 100.
100.
So 100, 1000 minus 100, which is going to be
900.
900. So the value of A that is being written in is going to be 900, right? So only at this point we are going to write the value of A, which is going to be 900. Then you are going to write the value of B. However, you perform a context switch, right? So the OS performs a context switch. Again, so what's the value of now only it's going to write the value of A. So what's the value of A that is being
900.
900 or it's going to be 950, right?
So we subtracted
Sir, but
temp now.
we aren't changing anything, right?
We already
After,
wrote A before, so it'll be 900.
So, right, so both the transactions are running parallelly. So you assume that the first transaction it has subtracted $50, but it has not written the value to that variable. So assume that now it's going to write the value to the variable. So it will be 950. A value will be 950. B value will be 2000. What's the B value now? So B value is going to be
2050.
2050. What's temp value now? Temp value. So B value is going to be
100.
100, yeah.
2050. So B value is going to be
2150.
2050 and B plus temp is going to be 2150, right? So 2150.
Yes. Plus 900.
Yeah, I think it should be 900 only, huh? 2150 plus 900, right? So right of A means we are going to 2100 and 950, yeah?
So it
Sir,
should be
because
900
in,
and 2150. So again, you
Yes,
have
sir.
inconsistency, but then the values will be different.
I mean,
Yes, sir. It'll be 50 extra because we didn't write it in the first.
Yeah, we aren't subtracting 50 from A, but we are adding it to B.
Yes, sir. So
so
that's why 50 will be extra.
yeah, so initially it was 900, then the value of A will be overwritten, right? So as I said, it will be 950, right? So this will be 950 for A and the B will be
2150.
2100. So the conclusion is that after the execution of the concurrent schedule, we arrive at a state where the final values of accounts A and B are going to be $950 and $2,100 respectively. So the final state is an inconsistent state. Since we have gained $50 during the process of the concurrent execution, and the sum of the accounts A and B is not preserved by the execution of the two transaction. So we say that, so what do you conclude? So we have seen a 4 schedule. So the idea is that if the transactions are executed serially one after another, you don't have any issues. The consistency property is preserved. However, if the transactions are executed concurrently, right, it's
So
not
basically, they should save the state before moving to another transaction.
right. That's it. To solve it, we have different mechanisms. We have some log-based protocols. We have some time constraint based protocols, so that the one variable will be accessed only by one transaction at a time, serially one after another. Right. So that solutions will discuss. So the idea here is that if you are going for concurrent execution of the transactions, right, it may leave the database in an inconsistent state. Right. So the final conclusion is that if the control of concurrent execution is left entirely to the operating system, many possible schedules may leave the database in an inconsistent state. So hence it's the job of the database system to ensure that any schedule that is executed will leave the database in a consistent state. Right? So you are not going to allow the OS to perform, OS performs context switch, but you are not going to allow the OS to take care of the complete execution of this transaction. So it's the job of the database system to ensure that any schedule that is executed will leave the database in a consistent state. So we have a concurrency control manager in the database system architecture. So it takes care of these problems and it sorts it out. So the final conclusion is that the schedule, if the transactions are executed serially one after another, you don't have any issues. You need not worry about the consistency constraints in a database management system. In schedule 3, you would have seen that we were executing the transactions concurrently, but however it results in a consistent state. But the thing is that not all the concurrent execution of the transactions results in a consistent state. So there are many cases in which the concurrent execution of the transactions leads to an inconsistent state. So we need to have a concurrency control manager in a DBMS software that takes care of these issues. Right. So that's it for today's class. So we'll study more in the next class. So we'll also try to study how to avoid this concurrency control problems. Right. So we have a separate chapter devoted for avoiding this concurrent execution problems. Right. So hope you can follow this class, right?
Yes, sir.
Yes.
Right. So anyway, everything is available in the textbook. You can have a look into it. We continue in the next class. So next class we'll study some other case study and so on, and we'll try to explain. Right. So thank you for your participation. I will meet in the next class.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.